Alrighty, welcome everyone. Thanks for stopping by. So today the theme we're going to be talking about is visibility into your network traffic within the Amazon environment. But first things first, we actually really take your feedback to heart, and one thing that we implemented this time is you'll see a little green dot at the bottom right corner of every slide, so those people who take pictures of the build-out slides we have, that's your cue to take a picture. So, but with that, my name is Miguel. I'm a partner solution architect here at AWS, specializing in networking, and we're looking to have Noop Dewani, senior product manager for EC2 networking. Awesome. So let's just jump into it. So like most of us, when we first started our journey in AWS, one of the first things we do is we launch an EC2 instance, right? Maybe we'll launch an RDS instance as well, right, because we have a database. Maybe eventually that database gets big enough to where we need EMR to get some more insight into it. And then other things, right? But let's take a closer look. So we're going to set the scene here before we jump into the nitty-gritty of network visibility. So we have Amazon EC2 with a VPC. Let's start off with a region. We're going to dive into the VPC here. Go to VPC CIDR of 10.1. You can expand it as well, and you can assign IPv6 addresses within that as well. A couple availability zones, some subnets here with some instances in them. Public subnets are public because they have an elastic IP address assigned to them, so the public, everyone on the internet can go and talk to them. Right? So we also have regional level services as well that live outside of your VPC but within the Amazon region. Now if we take a little deeper look here, right? So the Amazon VPC, they have route tables attached to the subnets. Or a couple routes in here, local routes, so all these instances in this VPC can talk to each other. Then we have all these different regional services again, and we have an internet gateway. Internet gateway is just a one-to-one NAT device that you attach to your VPC, and essentially all that does is says, I want my instance to be able to talk out to the internet. I'm going to assign that instance 10.1.0.11 with a 54 something IP, right? And that'll be able to access all regional services and also anything out on the internet. Great. Then maybe some instances in the private subnet need to go and talk to and get some updates. So they'll also go via a NAT instance. But really, you should be using a NAT gateway. It's built into the VPC fabric, so then it's a scalable NAT device that you can use. Awesome. We also have VPC endpoints. So if you don't want to have an internet gateway attached to your VPC, you can also talk to things privately like Amazon S3 or DynamoDB via the VPC endpoints. So you don't have to use publicly addressable IP addresses to then talk to these services, talk to them privately via your VPC. Then maybe you have an on-premise, right? We have a VGW, a VPN connection into that VPC, maybe Direct Connect. Maybe some of you guys are using that. Just building out our route table here. VPC peering, maybe you start off with one VPC, and as you start to add more, we have more VPCs into the mix. Connect those together. And then maybe you have hundreds of VPCs one day, and that's when you start to look at things like Transit Gateway, and we connect all of those. It's your central hub to interconnect thousands of VPCs and have a central point also for connections from on-premises, whether it be a direct connect or a VPN as well. Awesome. We also have Private Link. For those of you who have interested in Private Link, that little VPC up there would be like a service provider VPC where you're fronting a service with a network load balancer. And then from there, the VPC, your VPC has private access to that without ever having to go through the public space. It's all private, so direct VPC communication in this case. Awesome. We also have Global Accelerator, our Anycast service as well, and VPC Flow logs, which we're going to jump into here. And the reason I kind of level set us here is we have all these different components that can be used to talk in and out of a VPC. And you as an operator, you as a customer, want to get visibility into what's going on, right? To me, this is like, what is happening where? And we want to understand where those flows are happening. And this is your cue to take a picture if you guys would not. So how do I get visibility into my AWS network traffic? So Amazon VPC Flow logs. Flow logs have been out for a while. It's what customers have been using to understand what are the flows that are happening in my Amazon environment. And the flow log is essentially just a 5-tuple that gives you metadata about what happened with a specific flow, whether the traffic came in to the VPC or out of the VPC. And you can actually turn on flow logs on 3 different places. So you can have the VPC be a source, the subnet, or the EC2 instance itself, so the ENI. And then we can send those over to either CloudWatch or Amazon S3. And we're going to jump into those in a second here. But what does a flow log look like? Maybe some of you haven't checked that out before, but essentially the contents of a flow log are pretty simple here. We're going to build this out, so we'll all have a little green dot for you guys in a second here. So the flow logs version, so that's the version of flow logs that we have, so that's currently version 2. The account ID, so understanding what account generated that flow log. Also the interface ID, so that's basically the ENI's ID, so understanding what ENI generated that. The source and destination address, of course, also source and des port, so understanding that flow there. The protocol, so let's say it was a TCP connection, UDP, something like that. The amount of packets that were processed and also how big data transfer happened during that flow, right? So the amount of bytes that were transferred. Also the capture start and end window, so understanding how long that transfer actually took. And this one's pretty important. We're going to dive into this one because this is where you actually get the business value of why you should use flow logs is on top of understanding what happened is you can see whether the actual flow was accepted or rejected based on security groups or network ACLs that you assign in your VPC. And the log status as well. So that's your queue. So VPC flow logs are really a building block. So they don't tell the full story, but really what happens is basically they're metadata for things, for use cases like capturing IP traffic going to and from interfaces in your VPC. And also debugging security group and network ACL. So for those of you who have to deal with this, where developers are saying, well, I have these two instances, but they can't talk to each other. Can you help me debug this? You as an operator can go turn on VPC flow logs, understand what's going on, and then you can look for those reject statements. And then that'll help you decipher, oh, we need to open this thing up in the security group, and then that'll allow the communication. We're actually going to jump into an example here for that. So let's keep it simple. Let's just say we have two instances. We have VPC, two subnets, a couple EC2 instances here. Both have ENIs and two different subnets. And we're going to wrap them in security groups. So left side is security group ABC, and right side is DEF. And these are just the explanations of what's going on in that security group. But basically what's happening is we're allowing all traffic between these instances. So we're allowing that flow, and we can send those to flow logs. And we'll jump into the destinations, but we can send it to both of those. The question here is, do we have full connectivity? Yes, we do. And here's what it's going to look like when you look at a flow log. So when traffic is being sent from instance A to instance B, you'll see that accept statement. So when traffic was generated from A and going to B, you're going to get an accept statement. When traffic is generated from B to A, you're also going to get an accept statement. So we're good to go here. Now, let's have the example where someone misconfigured a security group. OK, so we have a VPC, a couple subnets again, two instances. We have an ENI, and then we have a couple security groups, so ABC and DEF. So we have both of the security groups, right? And essentially what's going on here is instance A can talk to instance B, but B can't do the other way around, can't initiate traffic back to A. So we have those red boxes there. Awesome. So we don't have full connectivity here. And here's what that looks like. So instance A to B, we have that accept statement because it was allowed. But now from B to A, we get a reject statement. So when you go and look through flow logs, when a developer asks you, hey, can you help me debug what happened? Why is my connectivity not working? This is a good place to start. And more flows. So some of the destinations we can send flow logs to, CloudWatch. So CloudWatch, you can send them natively there. And then you can build alarms and alerts based on things, right? So you can say, based on this ENI, if I see SSH traffic, tell me about it, and why is it getting SSH traffic when it's just a normal web server, right? All it's supposed to be doing is port 80, things like that. We can also send it to S3, and this helps you archive what's actually going on, so you can archive those VPC flow logs. And then on top of that, what's nice is in our documentation, feel free to take a picture of this link. You can actually use Amazon Athena to then go and query all those logs natively, and then understand, filter by an elastic network interface, and understand what flows happened over that interface. And it's pretty simple to set up. It's actually really nice. So you don't have to go and set up infrastructure to do this. You can go and query millions and billions of logs with Amazon Athena. Awesome. And there's also a use case where we had a customer who did customer-enriched VPC flow logs. So this was actually done by Netflix about 2 years ago at 2017 reInvent. You can watch the full video here. I'd love to talk about it today, but that'd be an hour talk on its own. And then there's also the case study here where you guys can check that out. So feel free to take a picture of that. It's a really good talk by the engineers over at Netflix. Awesome. But hold on a second. Didn't we launch something a couple weeks ago? I hope no one spoiled it out in the audience. But before we get into that, right, remember VPC flow logs are still very much useful. It tells you the metadata about the flows, but let's say you want to actually capture the actual packet itself. Look into what's going on in there. And so we launched VPC Traffic Mirroring, and we're going to have Anoop give you pretty much an intro of traffic mirroring.
Thanks, Miguel. Hi, everyone. My name is Anoop Dawani. I'm part of VPC product management team. And I've been working on this feature for some time, and we launched this feature called VPC Traffic Mirroring 2 weeks ago at AWS Reinforce. And the goal of this feature is to let you monitor your VPC traffic with the monitoring tools of your choice for use cases like threat detection, content inspection, and things like that. So in this the entirety of the session, we will actually cover this feature in depth, how you set up traffic mirroring, what you can do with mirrored packet, and things like that. So let's get started. So what is VPC traffic mirroring? Very short, it's like a fiber tap in cloud. Just like in your on-prem data center, when you have a fiber tap, you actually take the light on the fiber going, and you kind of tap it and actually make a copy of it, very similar to that. So if the light travels in two different mediums, you have an incident ray, a part of the ray gets reflected and a part of that get refracted. Traffic mirroring works very similar to that. You have packets coming over a network interface of your EC2 instance, and you can choose to mirror some part of the packet, and we'll get into details how you can choose to mirror what kind of packets you want to monitor. So at its core, let's take a quick example. You have an EC2 instance running in your VPC, and you have an internet gateway where you have traffic coming in and out. So this green traffic coming in and the purple traffic going out. And you decide to monitor this instance because this happens to be a very critical workload in your environment. And what you do is you create a traffic mirroring session. Up until 2 weeks ago, there was no option to create a thing like that, but now you can from your VPC console or using API or CLI. In order to create traffic mirroring session, the first thing you want to do is have a monitoring instance deployed. And you can deploy it in different places. We'll talk about that. But you need a monitoring instance and appliance in your VPC, across VPC. But you need something to actually send this packet to. Then you create your traffic mirroring session. And at a very high level, let's say that you have created a traffic mirroring session. What it's going to do is it will enable traffic mirroring on the ENI of that EC2 instance that you want to monitor. And once that's created, traffic that's coming in and out, now you can choose what type of traffic you want to monitor and send it to the mirrored instance, the target, which is the monitoring instance. So this is how traffic mirroring works at a high level. Now, what kind of monitoring instance you can use? There are few things. We'll cover all of these, but you can build your own traffic analyzer. You can use open source tools, or you can use one of the several partners, our partners from AWS Marketplace. We have around, Miguel will get into details, but we have around 20 plus partners at this time, which can provide you a solution for monitoring your traffic. So why did we build traffic mirroring, right? Well, our customers have been asking for this feature for a long time. And the reason they want to actually use traffic mirroring is for the primary use case here is detection of network or security anomaly. Customers want to keep an eye on that unusual traffic pattern so that you can figure out if there is any attack in your infrastructure, or you want to monitor the content of the packets, which will help you derive if there is any workload that in your environment has been compromised. All of that stuff needs you to look into the packets. You need to do the deep packet inspection, and this is what this feature is all about. The second important use case for traffic mirroring is troubleshooting and visibility. A lot of times, our customers who have pretty sophisticated applications deployed in their VPC, they want to monitor traffic between their microservices or application tiers to figure out those blind spots or choke points so that they can remediate that. Or if there is an issue that's happening in production, you want to look at how the packet captures between the applications are so that you can actually figure out what exactly is going on between the applications. So what are the key benefits of traffic mirroring? There are obviously our customers have been using traffic, are capturing traffic from EC2 instance. What they do today is they actually run a third-party agent on EC2 instance, which runs in the user space, and this agent allows them to mirror the packet or capture the packet as it goes in and out of a network interface. But the problem is that that's a third-party agent that's actually you have to install, you have to manage. It takes CPU penalty and things like that. The benefit of traffic mirroring is it's a native feature that you don't have to run any third-party agents for that. You actually are not, there is no CPU penalty, nothing. You just enable traffic mirroring on a specific interface on EC2, and that's it. The very important aspect of this feature is that this helps you improve the security posture as well. When you run an agent in user space, what's happening is you're copying packet from the user space. And if most of our security-conscious customers don't really want to accept traffic coming from user space, especially if that instance or workload is already compromised. What traffic mirroring does is we copy the packet off the network interface of the EC2 instance before it enters the user space, which means you can be rest assured that you're actually looking at the packet which was really hitting your workload. So there is no chance of tampering with this mirrored traffic. So that's a big benefit over running a third-party agent. And lastly, our customers have expressed that they want to monitor traffic using multiple tools. When you run an agent, you're kind of logged into one tool, but there are use cases where our customers want to have subset of traffic sent to a tool, one tool, and the other traffic to another tool. So that is possible with traffic mirroring now because there is no agent required. It's a native feature. You specify the destination of the mirrored packet. So now let's take a look at how do you configure traffic mirroring. There are essentially 3 components of traffic mirroring. It's a very simple concept, very easy to set up, and you just need to know 3 things. You need to create a target, which is your monitoring instance, which will be the destination for your mirror traffic. You need to create filters that allows you to express your desire to monitor the kind of traffic you want to monitor. And then you need to create a session which binds the source target and things. So let's take a quick look at each of this component in detail. Let's start with target. So target, as I mentioned, is the destination of your mirrored traffic. At this point, there can be 2 targets that you can have. One is the elastic network interface of a monitoring instance. So it's an ENI of a monitoring appliance that you just deployed. Or it could be a network load balancer, which is what we recommend actually. So you can run your appliances behind a network load balancer in auto-scaling group and have the real elastic solution in the cloud where your analyzers or appliances can scale up and down based on the mirror traffic. So a few things here. A target can be used by multiple sources, which means you can point or mirror the traffic from multiple sources and send it to a single target. You need to be careful that you do not overload your target by sending more traffic than what its capacity is, but there are also some limits here. When you have network load balancer, there is no limit. You can send as many mirrored traffic from as many sources as you want, and essentially network load balancer will handle that. You could run dedicated instance as a mirror appliance or monitoring appliance, and you can actually send up to 100 traffic from 100 source to that dedicated instance. Other instance types, if you're using for monitoring appliance, you can choose to send up to traffic from up to 10 sources to those instances. Another very important aspect is that you need to allow on your mirror appliance, in your security group, you need to enable or allow traffic on destination port 4879. The reason this is required is when we mirror the packet, we encapsulate that packet with VXLAN, making it a UDP packet. And it's a VXLAN encapsulated traffic that your appliances will be able to decapsulate it. Most of our APM partners that we're working on, they already have capability to either decapsulate or parse VXLAN header so that they can look at the mirrored packet after decapsulating it. Many open source tools like Zeek and Suricata have inbuilt capability to actually decap VXLAN header as well. So this was about target. Now let's take a look at the filters. Filters come in handy when you want to extract the traffic of interest. So let's take a quick example. You have again, coming back to the same example, you have traffic coming over instance on an EC2 instance where your traffic mirroring is enabled, and you decide to only mirror only inbound traffic. You trust any traffic that is going out of your instance is clean traffic. All you have to do is enable the filter, just say you want to monitor only inbound packet, and you're good to go. So before we look into filters, I want to actually talk about the encapsulated packet, right? How does this packet look like when it is received on the destination? As I mentioned, we encapsulate this packet with VXLAN header, making it a UDP packet. And by the way, after you decap the packet, you are actually going to get the layer 2 packet right out of the interface. So you will be able to actually even see the layer 2 headers that were on the ENI when we captured the packet. So how does this mirrored packet look like? The outer IP header will have the source IP of the mirror source that you're mirroring. The destination IP will be the IP address of the target, which is, if it's an ENI, we will derive the IP address, figure out the IP address of that ENI, and actually assign that. If it's an NLB, we'll actually figure the IP address of NLB as well. For the UDP, the only thing you need to keep in mind is that the destination port has to be 4789, which is a standard VXLAN traffic port. And then on the VXLAN header, you have capability to set VXLAN ID. So this comes in handy when you have a lot of traffic coming from a lot of sources, a lot of VPCs. You can, at the time of creating mirror session, you can give a unique ID or assign a unique VXLAN ID for each kind of source, and have your own logic so that on the receiving end, you can easily figure out where this traffic was really coming from. So now let's get back to the filters. The filters are very similar to a network ACL. This is, as simple as it can get. You create there are 7 options, very similar to network ACL, plus flow direction and truncation. So let's take a quick exercise, do the quick exercise, and create a filter. Let's say that I want to create a filter for all the traffic that's coming into my EC2 instance on port 80. I want to monitor that HTTP traffic. So I choose the flow direction as ingress. The protocol will be TCP, obviously. The source IP can be anything, so the traffic can come from anywhere on any source port. The destination IP would be my IP of the EC2 instance, and the destination port will be 80. That's all. There's one more option here, is do you want to truncate the packet? By default, we mirror the whole packet, but you have option to essentially specify if you want to just mirror first 200 bytes, first 1,000 bytes, whatever you want to mirror. We will actually truncate the packet and send you that length from the start of the packet. So in this case, I want to mirror the entire packet, so I will just skip that field. And this is how you create a filter, as easy as it can get. So this was filters. Now, quick thing about session. Session is the entity that binds this source, target, and filters. Session has 3 components, also source, target, filter, as I mentioned. And you can have up to 3 sessions per source. And this comes in handy because even though we mirror the packet only once, you can assign up to 3 sessions, and the session number is the priority. Lower the session number, higher priority that session has. And you could have, for example, if you want to say, I want to mirror HTTP traffic and send it to my HTTP analyzer, and then mirror the rest of the traffic and send it to another tool, you can create a lower session number, let's say session number 1, which will be higher priority, only capture HTTP traffic and send it to your HTTP analyzer. And then you can have other traffic other session where you capture all the traffic and send it to another tool. So this is why you can have up to 3 sessions and create this logic of sending subset of traffic to one tool and another subset of traffic to another tool. There are more advanced topics. I'll invite Miguel again to go over those topics.
Awesome. Thanks, Anoop, for that overview of VPC Traffic Mirroring. So let's cover some advanced topics here. But before we get too far, right, we just learned about VPC Traffic Mirroring. And let's do a quick comparison about what the difference are between VPC Flow logs and VPC Traffic Mirroring. So with flow logs, you get logs of network flows, right? It's just the metadata that tells you what happened within the flows. But with Traffic Mirroring, you get the real network packet that was sent originally to that destination. And with VPC Flow logs, we can send flow logs directly to S3 or Amazon CloudWatch logs. With VPC Traffic Mirroring, we send it directly to a mirroring instance or a network load balancer. In VPC Flow logs, like I said earlier, you can get a 5-tuple of the actual network flow for that specific capture window. And with Traffic Mirroring, you get the real network packet. If you guys want to take a picture of that. Great. So how does traffic mirroring affect the performance of my EC2 instance? So there's something to keep in mind here. And let's dive into an example of what that looks like. So we have network traffic flowing in through an instance, and it's being mirrored to the other instance. Let's say we had, the instance traffic, instance and mirror traffic both count towards your overall instance performance. And this slide is going to explain it for you. So let's say you had 1 gigabits inbound, you had 1 gigabits per second outbound. That means that the EC2 instance on the left side needs to support 2 gigabits of traffic, right? And so let's say we want to mirror that traffic. That means that the instance itself has to be able to support 4 gigabits of traffic. So that means that mirroring instance on the right side needs to be able to accept 2 gigs of traffic. So it's a simple math equation. If you send 5 gigs of traffic into that left instance, that means that that instance has to support 10 gigs of traffic. So you need a 10 gig, you need an instance that can support a 10 gig interface on it, and then you can only mirror up to 5 gigs of traffic. Let's see. So instance right sizing. So this is very important here. So we want to, that basically explains what I was saying earlier. You want to be able to make sure that the amount of traffic that you're actually sending into an EC2 instance, you have that enough buffer to be able to send the exact amount of traffic that's coming in to that destination instance. But one thing to note here is production traffic takes a higher priority over the mirror traffic. So let's say you are sending 5 gigs, but all of a sudden you get 6, 7 gigs into that instance that's generating or serving your production traffic. We're actually going to stop dropping we'll drop the mirror traffic and prioritize production traffic so it doesn't affect production workloads. So that way, if you turn on a mirroring session on an instance, you don't have to worry about it affecting your production traffic. So let's talk about scale. So auto-scaling, right? Where does auto-scaling come into play here? Let's say we have an instance getting traffic from the outside world. We also have an instance within the VPC sending traffic to it as well. We enable traffic mirroring. Let's say we have a network load balancer, right? We're going to send all our VPC traffic mirroring traffic to the network load balancer, turn on the session on that ENI. Now we have traffic flowing into the network load balancer. And it's being load balanced across multiple instances, and we're going to talk about how that hashing actually works in a second here. You can auto scale up to more instances, right? We started off with 2. You can scale up to 4 and many more. So in this case, let's say we start getting more traffic, right? Those are represented by the different colored boxes here. So as we continue to scale out and we get different types of traffic and more load, we can auto scale up behind the network load balancer to handle that mirrored traffic. Awesome. And the flow hashing. So what happens is all these different instances are all listening on port 4789 UDP port. And that's how we're encapsulating the traffic and being sent to those destination instances that'll process that mirrored traffic via the network load balancer. So the traffic is UDP only, and also UDP, the network load balancer now supports UDP, so that's great. The way the hashing algorithm actually works is it's a 5-tuple. And since the destination port is always the same, the entropy comes from the destination, the source port, the source IP, and the destination IP address, and also the protocol. So if you have traffic coming in into the network load balancer that's being mirrored, it could be hitting one instance behind the network load balancer, but depending on the new flow and the new source port, it could be sent to a different instance, right? So that's how we get our load balancing behind the scenes. That's what gives us the entropy in this case for the flow hashing. And you can also decentralize it. This is actually really cool. From day one, you're able to actually mirror traffic over a VPC peering connection to a different VPC. So long as you have layer 3 connectivity, you're able to mirror across not only a VPC peering connection, but also a transit gateway. This is going to get into, so you can have like a centralized InfoSec VPC off a little spoke off a transit gateway, and you mirror all the traffic. So long as full layer 3 connectivity is there, we'll mirror the traffic over that VPC. And that could have the network load balancer or EC2 instance as well. And it could be multi-account as well. So that's also great. So let's check it out in the console. We've been talking a lot about VPC traffic mirroring. Let's see what it looks like when we actually set it up. So I'll walk you through this. You're in your console. For you guys, it might be a little different, but in this case, let's say we had VPC in our recently visited services. We go over to the VPC console here. Click on that. We'll scroll down to mirror. So this is the section we want to look at here. I'm going to go over to sessions. I'm going to create a session. So it's pretty simple here. So there's a couple fields we have to fill out. We're just going to give it a tag. So just call it like traffic mirroring session. Give it a description as well. We'll just keep it the same, traffic mirroring session. And then we'll pick an Elastic Network interface out of the list. So choose that one. And then we'll choose a target. So we have to set up a target instance that we're going to mirror all our traffic to. Awesome. And so we'll scroll down here. So you can give it a session number. Session of 1 is fine for now. You can also specify the VXLAN ID, and we're going to jump into that in a second here. But if you don't specify them, we'll pick a random one here. Also the packet length. So you can actually truncate the packet and tell us how much of the packet you actually want us to mirror. So if you only want let's say it's HTTP traffic and you want to just truncate enough to capture headers, specify the amount of bytes you actually want, and you could do that. All right, so in this case, we're just going to leave it blank, and it's going to give us the entire packet here. We're going to create a filter. So the filter, this is what Anoop was talking about earlier, is you can actually say, I want traffic from port 8080. It's TCP-based, so I want the TCP section, TCP, and also give me all the traffic that's accepted. So it's still same concept from VPC Flow logs, right? We still have that same concept here. And give me it from any destination as well. Great. So we create it. Just expand this, kind of small, but I try to blow this up for you guys. Essentially, this is what you end up getting there, and that's all the metadata that tells you about that specific mirroring session. So what do you actually do with the packets? Okay, we've been talking about traffic mirroring. Okay, that's great, right? But what do we actually end up doing with the packets? Well, we have our APM Partners can actually come and rescue you here. Essentially, we launched with 20 partners on day 1, so that's actually pretty solid here. All these different partners that you see on the screen, you got Nubeva, you got Cisco, NetScout, all these people are ready to help you with VPC traffic mirroring today. And also this slide too, we got people like Symantec, Big Switch, FireEye, Okay, so those are the APM partners, and that's absolutely the route to go if you want a solution that's already built for you, and you just send your traffic to them, they give you a single pane of glass, great. But another thing we thought about, me and a colleague put this together, what if you wanted to build your own analyzer? For all those DIY people out there, let's jump into some code here and check out how you can do this. So let's have a simple example here. Let's say we have a web browser. User's making an HTTP request to 3.254 port 8080. we're going to capture those HTTP requests. So what does that look like? We're going to capture both in and out. So let's build the analyzer. So we've got a terminal window here. I'm going to spin up a Vim session for all the Vim fans out there. So this is written in Go. And really, the simple thing here is we're just importing a couple libraries that's going to allow us to do a PCAP capture for all the traffic that we're getting mirrored to us. We're going to actually process this here. So these are the libraries that we're going to use here. Now we're going to jump into that. Inside of the function main, we're going to look into the agent code itself. So let's define the analyzer. So what happens is we bind ourselves to an interface, right? So ENS5 is like a EC2 network interface name. If you do an ifconfig, you'll see the names. So that's what we're going to bind to. We end up getting a handle. And with that handle, we can actually set some filters. So what we're going to do is instead of getting anything, we're going to look for UDP traffic because that's what we're end up going to get, right? So traffic mirroring packets are going to be encapsulated in a UDP packet that has VXLAN inside. Cool, so we set a filter there. And now we have a packet source. Now we can actually look for packets. For those who want to take a picture. Great. So let's grab the mirror packet. Next step here. So we're just going to do a loop. We're going to loop forever, and we're going to get the overlay packets. So every packet that comes in, we're going to process it. First thing we're going to do is see if there's a VXLAN header in there at all, right? We don't want to process things that we don't want to process, right? So if there is a VXLAN packet, great. We're going to grab the packet inside of that encapsulated packet. So that original packet that was mirrored, we're going to grab that packet. And in this case, we're just going to dump it to the screen, right? So if we build this, and then we run it, we're just going to get a big PCAP dump, right? So all the layers and basically all the output of what that packet was originally. But many of you are probably thinking, okay, so what is all this, right? So let's capture the HTTP traffic. So we just got a full packet in that case with that simple little script we wrote there. Now we can actually look for specifically what we're looking for here. So now we have that same piece of code up top, right? We had that original packet. Now we were writing some code to go deep into the actual application layer. The library provides a nice little handler here that allows us to just grab it. We're going to look for HTTP in the payload, see if it's there. Great. So there's probably an HTTP request in here. And then we did some other fancy things here to show you the actual flow back and forth, right? So this code will give you that. And all we're doing is just grabbing HTTP requests, right? So that's the TLDR there. So let's build it again and see what output we get. So we have the traffic mirroring destination. So that's the instance target that you set up, the traffic mirroring target. We're going to build the code there, have it run in the background. We're also going to have the traffic mirroring source. So this is that HTTP server we're going to run that's facing out to the internet with the port of 8080. And it's listening on port 8080, waiting for requests. Get a web browser. I go to that URL, the IP address, port 80, boom. And so now the HTTP server responded to me, but also that traffic mirroring destination target instance got that entire flow that happened, both the HTTP request in and all the responses back. So as you can see, I mean, this is a pretty powerful model for those of you who want to build specific workflows around this. With a few lines of code, we can actually get something going here, right? So it works. So done, right? But what can we do from here? So we can send these things ourselves to S3. You can send it to Kinesis, also to CloudWatch. Some things to consider here, given that you're building your own, you want to think about scale as well. You got to have some buffering techniques on the instance, because if too much traffic is going in, you can only send things to S3 so fast, right? There's only a certain amount of requests per second. So you have to implement some sort of buffering here. Keep on the lookout. I think we're going to write a blog on this pretty soon here and put this public, so we'll have more information about how you guys can jump in here and do this yourself. But if you also are interested in the code, shoot me an email. I'm going to have my email at the end, and I'll send you the snippet I have now. Awesome. So we talked about building your own analyzer. We also talked about APM Partners. There's also open source tools. We actually have this in our documentation. Zeek and Suricata, we have the documentation on those guys if you want to check those out. Some open source tools that'll get you going, give you that happy medium between building your own analyzer and using an APM partner. And also, here's a link for you guys if you want to check those out. So any other considerations? Noop, do you want to let us know?
Thanks, Miguel.
Yeah.
So We covered a lot of things. I want to reiterate that there are a bunch of webinars that we are doing with our APM partners. There's a lot more you can do. You can actually figure out the sophisticated attack. If you have an alert coming in, you can actually really dig deep, and these tools can allow you to figure out what exactly is happening in your environment. So, I just want to make sure that, if you have a partner of your choice that you don't see in the list, shoot us an email, or look out for the webinar for these partners, right? But coming back to traffic mirroring, there are a few things that you should be aware of. One is that mirror traffic on the source is not subject to outbound security group. This is important for our security conscious customers, because if they want to mirror traffic, they want to make sure that they're keeping an eye out on every single critical workload. You don't want the developer or anybody else to actually just block the mirror traffic by installing a egress security group to just block the VXLAN traffic. So that is the reason we made this conscious decision where mirror traffic will bypass the egress security group. And for the same reason, mirror traffic will not be captured in the flow log. So it is for the administrator. The feature is primarily for the security team, where they can choose to enable mirroring on certain workloads where they want to monitor, or they want to do incident response if they have figured or found out an alert that's been generated on CloudWatch or Guard Duty or things like that. Another aspect, the packets that will be mirrored are the only packets that were passed or allowed by security group and network ACL on the source. So the traffic which will enter the EC2 instance or the source is the traffic that we will mirror. So in other words, if on the source a packet is dropped because of security group, that won't be mirrored. Mirror traffic is considered as a standard traffic. So all the inter-AZ data transfer and other things do apply. So, but you have a bunch of options. You can actually have an appliance within an AZ and essentially send all your traffic from source to a destination and have them all in the same AZ. But I want to clarify that mirror traffic is a standard traffic, standard UDP traffic, which means you need to make sure that you have the routing configured correctly as well. You need to have connectivity between the source and destination. Now that destination, as Miguel talked about, can be in another VPC, another account, connected via transit gateway or via VPC peering. But for that to make it work, you want to make sure that you have routing configured correctly. And Miguel already mentioned that we will prioritize production traffic over mirror traffic. Again, we don't want to get into a scenario where you start dropping packets on the production application because you enable traffic mirrorings. And be careful of the MTU size. Since the packet is encapsulated, there is a 56 bytes of overhead. So if your target is configured with an MTU of 9,000 and you're trying to actually send 9,000 bytes of packet from source to destination, we will truncate the packet at 8,946 bytes. So a quick workaround there is that you can set your source to have no more than MTU size of 8,946 bytes, so that all the packets that are mirrored will be within the MTU budget of the target. And that were some of the considerations, right? Now let's take a quick look at how our customers are planning to use traffic mirroring, right? We talked about all this thing, but in a very short span of time, what we have seen, so it's been 2 weeks that we launched this feature in 15 regions. But we are seeing some cool stuff here that our customers are trying to do, and a lot of use cases are getting unblocked. Our customers are now trying to use traffic mirroring to continuously monitor sensitive workloads, which they want to keep an eye on. Second is when you have acquisition, when you're merging environment, this feature comes in handy. You can enable traffic mirroring on the workloads of the new environment that's merging in, and really figure out what actually traffic is going in and out of those workloads, as opposed to what you have been told by other administrators, right? So you can have a lot more data about the new infrastructure that's merging into your environment. And then this is actually really cool feature for on-demand incident responses, right? So I will go through some of the workflows in the next couple slides, but this feature totally unblocks how you go and dig deep into traffic when you have seen some alerts, some security alerts. So the automation here is key. There's a small typo here. So the key here is that automation workflows are the key here with traffic mirroring. So let's take a look at how our customers are actually using this. So I have last couple of slides here, which will give you an idea about how you can build this whole workflow. And we will actually post this code on GitHub so that you can leverage it as well. So you have EC2 instance that you have in your environment, and you have, let's say, some good green traffic, which is a good traffic which comes in and out of your environment. Everything is fine. But for some reason, you see this purple or a blue traffic, which is bad traffic that is coming in now. And what happens is that guard duty comes in, and it generates an alert that something is wrong. But until 2 weeks ago, you would actually just stop there, right? You will actually have to have human dig into it. But now you can actually take alert, enable an Lambda event, trigger the event, and Lambda can actually now go and figure out where this alert was generated and on which ENI there is a potential problem. And now what it can do is it can automatically spin up a monitoring appliance for you. So for example, you have a monitoring appliance where it's in the same VPC in this case. It can be in a different central InfoSec VPC2. It will now then go and enable traffic mirroring for you on that ENI. And once that's enabled, you have automatically all the packets that were coming in and out can go to your monitoring appliance so that you can now really look at what was this alert about. Was it smoking gun? What was really happening here? That can be done automatically. You can actually also, so some of our customers are using open source tool like Zeek and Suricata, which can monitor the traffic for you, tell you what's happening, and also generate logs. That logs can then be sent to S3 for archival purposes, for record keeping, or for whatever other use cases you want to have. Also, that logs can now be queried through Amazon Athena so that you can actually provide these logs to humans who can do a high judgment call, right? Whether to install a new security group, whether to terminate this workload, do whatever you want to remediate that, right? So this entire workflow has been, we have customers who are already trying to use this. And what we'll do is over a period of time, we'll actually try to post this workflow on GitHub repository so that you can just use it in your environment. So that was one thing. The other, yes, so the other build, sorry, the slide has more build out. So then you can actually use, once the things are done, you have remediated the problem, you can actually clean up this environment too. So Lambda can actually go terminate the monitoring instance if you want. It can disable the traffic mirroring, and that's how you can have the incidence response going for a particular alert that was generated by either your tools using flow logs or guard duty. The second thing is pretty similar thing that our customer is using is instead of guard duty, there's a human that generates a request for incident response so that the request goes through API gateway, and then the rest of the stuff is exactly the same. Lambda script come in, monitoring appliance gets deployed, traffic mirroring gets enabled, and then you start getting the mirrored packet. And then obviously the logs can be sent to S3, and some human can actually read the logs. There's one last thing that is also our customers are doing. I want to actually make sure that you are aware about that is, let's say that you have an environment where you have traffic mirroring on and everything is working. You send it to network load balancer as a target, which is what we recommend, by the way, because you don't know how much traffic you're going to mirror. Send it to network load balancer. Let network load balancer take care of the high availability and scalability aspect. And you have everything working that we were talking about in the slides, where logs are shipping to S3, and then somebody can query through Amazon Athena. What you could do is you can actually tag your application. So there are use cases for our customers where they want to enable traffic mirroring on every single ENI in a particular environment. For example, if it has a tag XYZ, which is a critical workload, they just want to enable traffic mirroring. So what you could do is, in such case, for example, here I have another monitoring instance that was deployed, and I want to make sure that I don't go and enable traffic mirroring on every instance because that's not scalable. What you could do is you could have CloudTrail, where CloudTrail can tell you what instance was deployed or instantiated, and a Lambda script or Lambda event can be generated. Lambda can figure out what was the ENI of this instance which has tag XYZ, which happens to be a very important workload in my environment, and then that Lambda can actually go and enable traffic mirroring on this ENI as well and send it to network load balancer so that you have a continuous monitoring of your workload without you actually babysitting every workload that's coming in up and down in your environment. So all of these things are happening. Our customers are doing it. Very large customers, even essentially even the large scale customers or small scale customers, they are actually trying to do this automated workflow. And we actually highly recommend using these workflows so that you have automation, you can scale with this feature, and keep an eye out on your environment so that you have peace of mind and you know that your environment is safe. Miguel, do you have any final thoughts? So that was my part. Miguel.
Yeah. Well, first of all, thanks everyone who stuck around. We talked about a lot of stuff, right? We talked about VPC Flow logs, talked about traffic mirroring, and really with flow logs, right? When we turn those on, we get the metadata of what's actually happening with flows, right? And that was what customers have been doing, and it's been really helpful for all of you guys who wanted to troubleshoot network ACLs and security groups and what's going on. And also with traffic mirroring, we saw some use cases where we can use APM Partners, Amazon Partner Network, use their solutions to be able to get a single pane of glass and understand what's going on in the environment. We talked about some of the DIY stuff, right? So you can build your own analyzer. And we also looked at some of the open source tools, right? Traffic mirroring is, we're starting to get more use cases, especially from you guys. We love the feedback from customers. We're looking at things like live traffic, like you basically can mirror the live traffic and test your workloads, things like that. We're looking into things like that. So it's just beyond just not even just mirroring traffic, right? There's workloads beyond that can be attached to it. And so I'm going to leave you guys with a quirky quote here. So Confucius once said, "To practice 5 things under all circumstances constitutes perfect virtue. These 5 are gravity, generosity of soul, sincerity, earnestness, and kindness." And with that, we love your feedback. So if you and please leave some session feedback. We really appreciate it. We take your feedback to heart, and really appreciate you guys coming out here today. Thank you. If you want the slides, that's my email.